let's move on to our next esteemed speaker for today. We're very, very fortunate at SingularityNET to have Deborah Duong, CTO of Rejuve, with us today. Dr. Debbie Duong is our leading visionary AI female scientist at SingularityNET. She has been a staunch supporter of all things decentralization, diversity, inclusion for decades, similar to myself, but coming at it from an algorithmic perspective and from a systems perspective. Debbie's been researching this field for at least 2 decades. I'm sure she can correct me on this. And it's my great pleasure, my great honor to work with Debbie and to introduce her to you today. So as CTO of Rejuve, SingularityNET's AI Health and Longevity project, Rejuve Network, Debbie is ideally placed to understand the impact of decentralization on technology production and its potential to create ethical, open, and just artificial intelligence. Over to you, Debbie. Really looking forward to your talk.
Thank you, Janet. You're just too kind. Okay, so today I'm going to talk about how Rejuve AI is trying to create a just society through algorithms of decentralization. And we start with the premise that injustice comes from infrastructure and that Web3 can create new infrastructures that, with careful testing, will be free of injustice. So with this philosophy, we invented our tokenomics system. And Rejuve AI's tokenomics rewards data and model contributors for their proportionate contributions to AI products, keeping track in the blockchain and distributing proportionate payment with every sale of an end product. So you can see the purpose of the tokenomics is to keep track, but what is it that figures out the proportionate contribution? That's Rejuve AI's decentral AI. And our decentral AI for decentralized science promotes fairness of participation by enabling scientists to submit smaller models that an AI combines without bias and determines that proportionate contribution. So let's delve into this a little bit, starting with the origins of injustice in infrastructure. Well, first of all, there's a problem of capitalism, the problem of the arbitrage of labor. That with traditional money, you can forget where the value came from completely. And because you can, that's what people did. Okay, so workers don't see the profits that their work has generated. So I see that as a technology problem. The technology of traditional money doesn't support the feature of workers being able to see the profits that their work has generated. Capitalism is winner take all. Monopolies form, infringing on the free markets. And there's tribalism and bias in it. That the more powerful define the less powerful through systemic misperception. So today's data economy has changed capitalism, but I believe it's changed it for the worse, mostly. And we're going to talk about how it might how we might change today's data economy for the better with Web3. Well, why is it worse? Well, think about it. PageRank accelerates winner take all because PageRank isn't passive. Everybody goes to Google to find out what their products are. So there's a feedback loop in which there's kind of this self-licking ice cream cone going on where everybody promotes each other in a kind of a corrupt system where people believe in each other's competence based on a tribalistic perspective rather than being decentralized. And AI typically reproduces the biased culture of capitalism, all the tribalism in it, all the corruption, and all the sexism and racism that's in there. the payments for data labor are one and done, even more so than in traditional capitalism, which at least if you're making consumable products, there's continued demand. But once you give your DNA away, it's gone forever, and you're forever separated from any value that may come of it. And today's AI, we can see with the generative AI and the chat GPT, is quite possible to give us a resource curse, which is a term in economics used for countries that have a great resource like diamonds, and their people are cursed because their people's contributions are no longer needed or valued. And all an economy is a recognition of somebody's value and their contribution. Today's chat GPT and other generative AI divorce the output from the input that it recombines. And our purpose is to keep track of what it's recombining and give credit. So Web3 and AI create a new infrastructure for the data economy. How can we make this new? AI can recombine work instead of capitalist arbitrageurs and determine a proportionate contribution. Blockchain can keep track of who contributed to a product and reward them with every product sale. This results not only in fair credit for products, but better products because they are more effectively crowdsourced. It gets rid of all that mythology of who made the product or of celebrities or stars. And it completely decentralizes it into ideas whose time has come. Our decentralized AI, which is we call our generative cooperative network, allows all scientists to help make contributions and receive fair credit for their models in a systems biology consensus model. Okay, so as we stated before, the creation of this model is supported by tokenomics. And the principles of that tokenomics is that secure ownership and control of data reuse is primary. That we have fair compensation for data and intellectual property contributions. That there is a permanent record of contributions for future tasking and compensation, and transparency in pricing and consumer choice. Our tokenomics have 4 tokens. The first, our Rejuve utility token that we've recently released, and it's for transactions between network members. Our network members can comprise of people who contributed data, modelers who contributed models, people who consume those data and models, AI that consumes it and creates hypotheses for products, places that create products, places that make measurements that the network users can use to create data and contribute to the network. Many different sorts of people in the Rejuve network. The data NFT, and this is 1 NFT per data contributor, keeps track of who has permission to use your data. And then the product NFT, there's 1 per product idea. And that keeps track of all the data contributions that ended up in the product. And it ensures the proportionate payment in Rejuve with each product sale. And then finally, when we have our challenge pools, staking pools, we have a product NFT coupon. They're given to stakers upon the achievement of a scientific goal that's slated for a pool. Like if there's a scientific goal, then data contributors and modelers are incentivized to win that challenge and have people in the staking pool receive coupons that can buy their products. So how does our decentralized science work with these tokenomics? How is it that we're able to decentralize science and give back the proportionate contribution to the contributor? Well, the labor in a data economy includes both the labor from one's body, like personal healthcare data, and from one's mind, like intellectual property. In Rejuve AI, the AI performs a recombination of labor instead of the capitalists. So there's no arbitrage of that labor. There's liquid employment, regrouping and reuse, so that you're not dependent on your employer to define you. You don't have to convince an HR department that you're going to do a good job. You can just do a good job, a small good job, and profit from it for all time. Each network member contributes a small part that they themselves defined, and which gets combined into a greater whole. Now, the AI that recombines those smaller parts does so fairly because it's based on the concept of blindness. Blindness as in the blind audition, as in blind justice and the blind randomized control trial, so that people aren't placed according to corrupt tribalism or racism, sexism, anything like that. It's a fair selection based on merit and not subject to human biases. So our generative cooperative network, which is our AI that uses the contributed models, recombines both data and generative models into mixtures of experts that solve problems. So, we've heard recently that the idea of one large language model is going out, and the way that you can't just keep getting an improvement with one large centralized model. We need to study how to decentralize them and how to give them back to the individuals who created them. So that's what the GCN does. Generative models within the GCN talk to each other, but in their own emergent language, to perform multiple goals related to our task of modeling the human body. From individual contributions and under many challenges, mechanistic systems biology models emerge from the many individual contributions. Agents compete for tokens in a simulated market to create a dynamic multi-resolutional mechanistic simulation. Agents earn those simulated tokens by completing challenges, multiple challenges related to the system they are simulated. So there's a simulated market with multiple agents that employ each other, and they cooperate because they employ each other, but they also compete because they're in different teams that self-organize and assemble into ways of completing a challenge. But there's many challenges that the teams create, and that helps to make the language with which they talk to each other come to mean their role requirements and come to direct them into having a better team and a better way of relating to each other. And that's how the GCN helps the individual models self-organize into solutions and true deep reals of how the human body really works, because is subject to reinforcement learning and is subject to measurement. Agents earn their simulated tokens while completing the challenges related to the system they're simulating. So it might be an individual team is simulating the respiratory system, or it might be the immune system. They come to specialize in different areas that human beings also might be specialists in, and contribute models in those different areas to make a mixture of expert models. The emergent market price of the contribution of the data model within this emergent, within these multiple simulations of markets, becomes the assignment of credit of the model. Like if a model comes to be valuable in many different, to solve many different challenges, then it raises in price in the simulated market, and that becomes the price that the creator of the model gets in proportion to the other prices of the winners of the models, of the challenges. Okay, so now we're going to talk about how it is that the generative cooperative network can decentralize science. And it uses the concept of complex adaptive systems to do this. The basic idea behind the generative cooperative network is that it is the concept of signaling and signing. Human beings are the symbolic species, and those symbols with which the individuals talk to each other really contain all of the accumulated knowledge that they have. And if you look at humanity as a kind of a multi-agent reinforcement learning system, that language there is the accumulated knowledge of the system that forms an upper level of institutions and culture that restrains the agents and directs them into what is what has worked in the past, right? But that is combined with the individuation of the individual agents and their will to utility, which is the reinforcement learning aspect, and their ability to change that language towards something that's useful to them. So there's this upper, lower, micro, macro integration in society that mixes individual utility with emergent level processes. And that's what we use to make those individual models into one complex adaptive system that uses systems biology concepts to simulate the human body. So what are some of the features of that? For one thing, there's emergent signs in the GCN. I don't tell a generative network how to talk to another. Yes, it may start with English, but it can develop any language it wants to. And that is what makes it more powerful, or makes the group of generative networks more powerful. But as long as we have the goal with which they're trying to get in the market, we can control the purpose of their talking. And that purpose comes to be a role requirement list. Like if an agent wants another agent to perform a task, a subtask, they have to be able to indicate to that agent what it is they want them to do. And the cultural part of the signs that emerge tells what stakeholders in the past have found beneficial in their trade, so that the ones who won and got more tokens, that came to be the meaning of those signs. So we use emergent signs in the GCN, such as signaling in living systems, to coordinate lower level entities into emergent upper level systems. And the GCN uses signaling for self-organization, but also for open-endedness and emergence. Why is it open-ended? Well, because it's flexible. We'll talk about that a little bit more. Open-endedness, self-organization. Because those signs are slippable, fuzzy, and open to different meanings from different agents who use them for different things, that ambiguity gives them a chance to employ each other based on a meaning that can change. Okay. Agents, those signs come to mean roles for agents, and those are changing roles. They're not based on individuals. If the only thing one individual learned was to employ one other individual, then the other individuals couldn't come in on the idea. But since they look for each other based on roles, then any agent is free to always perform a role and be up for employment by another agent and replace them, given that they have a sign that the agent is seeking. The signs create a functional space or even a culture that accumulates the past innovations, and it's interpretable. The implicit signs come to have implicit meanings, but they can be interpreted to be explicit within precise instructions once they become gelled within the simulation. There's similar signaling dynamics going on. There's what we really are doing is we are emulating the social emergence of symbols from sub-symbols via symbolic interactionism, which is a concept in sociology. But it's also inspired by Smolensky's concept of the emergence of symbols from sub-symbols in neural networks. And I believe these are really one and the same idea. The role of signs is that signs start out arbitrary, but gain meaning as both the displayer and the seeker induce it based on token acquisition for their utility, right? They start out arbitrary, but come to have meaning as over and over again, their meaning is induced. So that's how they represent requirements rather than implementation, allowing flexibility and adaptability. Agents can specialize in various areas, forming concepts based on problem solving, and those concepts emerge from subsymbols in a process based on agent culture. Okay, so what happens in a multi-agent simulation? Well, there's a Nash equilibria going on. The meaning of symbols increment towards the many stakeholders' utilities over time. They almost settle on places where it's hard to change out of, and that's called the Nash equilibria, until there's an inventor agent, and those inventor agents are new agents. There are young agents that aren't converged yet, who are able to implement the requirements in another way because they are other AIs. And so there is emergence of coordination in the GCN via signaling. And this is what is required for the multi-resolutional simulation to mechanistically form and transcend the lower level into the upper level systems biology model. Okay, finally, that's those new agents that come in on society and have a functional space. Well, they have an exploration exploitation dilemma. They know what is the path that agents have gone on before because it's in the language. And they follow a path in that vector space to optimize their income and skills that they happen to be good at because they're a certain kind of AI. But that exploration aspect stems from the new agents' neuroplasticity and diversity, but the exploration aspect stems from the functional space and agent culture. And so those agents that optimize this trade-off between exploration and exploitation will reach that edge of chaos, which is optimal for problem solving. And that's why we have an open-ended evolution in the GCN. And that is based on all the different people's contributions and no one overarching contribution. Okay, that's my talk. Does anybody have any questions?
Hi, Debbie. Thank you for your absolutely scintillating discussion. And one of the things I really love about you, there are many things I love about you. Shall we stop screen sharing now and just chat for a moment?
Okay, if I can figure out. Okay, there you go.
Yeah, one of the fascinating things about you is the way you approach decentralization and ethics and science from an engineering perspective. The majority of the rest of the world are approaching it from a regulation perspective or a ethical principle perspective. But you're actually down in the weeds, driving the algorithms that drive for better fairness and for better decentralization. What do you think is the balance required between policy on like the regulatory ethical frameworky side and engineering, and how can we get more scientists to take the same kind of approach as you?
Oh, okay. Well, all the policy concepts, as long as they're measurable, are subject to engineering. Like you talk about democracy. Is this a democracy or not? Well, can you define democracy? Can you define it so well that you can measure it? If you can define it so well that you can measure it, then you can engineer democracy, right? If you can engineer democracy through, let's say, a tokenomic system or a blockchain system, then you can simulate that and then you can prove it. Like, as you know, a lot of people in blockchain are working on things like making sure there's not a double spend, because that would be horrible, right? If you paid somebody and then, you didn't have your money. And that's so horrible to them that they're willing to devote their time and efforts to ensuring that that double spend doesn't happen. Well, what if we were just as motivated to ensure that democracy happens, right? As long as we can define it, we can simulate it and make sure that the policy of democracy is implemented. And so once you can ensure the implementation of democracy, then you can let somebody tell you their policy wishes and say, oh, I've come up with an implementation for your wishes.
Okay, so all of the ethics and regulation and principles you think can actually then be digitized and programmed effectively into the engineering life cycle.
Yes.
From start to finish.
They definitely can, yes.
That's very, very inspiring. I remember in my banking days, one of the problematic issues we used to have was making gray area decisions in an ever evolving society with changing ethical norms. So I was in a global banking role across 64 countries, and so like the easy stuff is someone doing something wrong, someone doing something right. That's simple. But when you get something coming into the gray area of decision making, that's when the human really needs to get involved, right? And that's where you need a broad aspect, a broad set of perspectives coming in. How do you think technology and AI will be able to actually cope in that gray area, in that gray space where things are?
Why is something gray? Why is something gray? Because there's a trade-off, right? Why is there a trade-off? Because of the infrastructure. The infrastructure creates that trade-off because you do not have some technological capability to make that not a trade-off, right? And so going deeper into the infrastructure, into the blockchain, how can we invent systems where those two things are not traded off, those two goods?
Yes.
And there are different ways we can do that. Let's look at what are some of the problems now with the data economy and maybe having PageRank determine who gets to even know who in advertisements. So only a few people that are the smart people get to be chosen for employment. Let's assume that's not fair, right?
Yeah.
So what's the root of that? That's a root in business models that have advertisements and clickbait and all of that. And how can we change that technology underlying that business model so that you don't have to have, people enraged so that they click more, and the business model is fueled by non-socially acceptable things. How do you do that? Well, let's get back to how does a consumer choose, right? If the consumer chooses just because of the first thing they see, then that's what fuels the clickbait. So what if we made it so that the consumer can choose another way, like perhaps choose according to their values? What if they stated their values and on their browsers before they ever used them, that they wanted a company that had equity or that paid their people through equity and didn't pay one guy and gave him all the credit and made everybody poor, or that it was green or whatever, right? They could, through infrastructure, because we have blockchain, keep track of the transactions and measure how much this product or that product fulfills one's values. And you can use Pareto optimization. You can do different algorithms so that you can have multiple values. And then suddenly, instead of chasing only what increases shareholder values alone, people would start chasing what increases green because that's what the consumers wanted. So it's a matter of infrastructure.
Okay.
Things that are trade-offs and make them not trade-offs.
Well, I absolutely admire the intent, and we've got people on the YouTube channel talking about it. BCM Strategy Inc. says his company does measure public policy risks objectively using award-winning technology. I still come back to, I guess, probably the need for the human in the loop in edge cases, because I remember having to make decisions myself that were so non-obvious, and I would.
Okay, I didn't say there wouldn't be edge cases. I mean, change them.
Sorry?
I didn't mean there would never be edge cases. I mean, keep moving what the edge cases are. Move the edge.
That's right. That's exactly it. Move the edge. That's exactly where I was going to. Thank you so much, Debbie. It's like you read my mind. Brilliant. Right, we are now, I am only going to let us overrun by a maximum of 4 minutes. But let me ask very quickly a couple of questions coming in from David. Thanks, David Wood. He asks, what is your definition of democracy? He also asks, in what sense can an LLM be more or less decentralized? With OpenAI already collecting data from as many sources as possible, is the difference in how the RLHF, reinforcement learning customization layer, is operated? Do you want me to write that for you, Debbie? While you take the first one, you take the first one. Yeah, or you got it.
I don't want to define democracy because I'm not qualified to do that. But I could point out that voting is a complicated thing. And one thing you have to do is make the infrastructure such that voting is done by people, because, a lot of times they don't want to get together in the DAOs and spend their time on it. How is it that you can make people vote with their feet more? Like make their preferences part of their everyday interactions. Like for example, I just said the consumer can vote with his feet by stating his moral preferences once, and then he doesn't have to worry about it anymore. But that has a lot of implications for for the incentives in the companies, right? So democracy is broadly defined, and certainly anything that prevents any kind of autocracy would be democracy. So, but I don't really want to say that I define that. And reinforcement layer, let's get to that. How can LLMs not be their big prejudiced models that they are? Well, LLMs are models that can take English in, but they can also take in images, they can take in human body data, DNA data, they can take in a multiple variety. Transformers can take in all sorts of data. And the human race is just one example of one biased set of agents that talk to each other. We can make agents that talk to each other through their own languages and through their own data, or the data that we give them. And instead of have them hallucinate concepts that match the hierarchies of the society, that are true in the sense that they are the true ways of oppression, right? But not true in the sense of being correct about somebody's skills or the perception of somebody, right? Well, what we could do is have those LLMs learn concepts that create better and better and truer models of the human body or of society that see into the true causes rather than concentrate on the correlational false causes, right? And how do you do that? You do that with reinforcement learning, because you combine multiple, not single goals, but multiple goals over and over again until the model is forced to be causal. That's why.
Brilliant, thank you. Brilliant, thank you. And reinforcement learning, of course, lends itself really well to a human in the loop reinforcement layer as well at the same time. So with blockchain, Debbie, you've been absolutely amazing. Always a total inspiration to see you. Thank you so much for your time here today.